Hi, I'm Will from Tested.
And I'm Norm from Tested.
Norm and Chan, there is a lot of 3D printed stuff directly in front of you.
That means today we're going to talk about 3D printers. Well, specifically, the Printrbot.
Yeah, so about a month and a half ago, maybe 2 months ago now, we actually built this printer right here at this desk. It took, let's say 3 or 4 hours, probably all told, and we built it from a kit. So this is the Printrbot Simple Metal. It's $599 assembled, or if you want to be like us, you can buy the kit for $60 less, $540.
And since we shot that video in which we talked about how poor the instructions were for building this Printrbot Simple kit, they have improved that.
We talked a lot of mess about the instructions we were building it. They were, quite frankly, pretty bad. I'd say that they were probably already in the process of updating those instructions because they've set up a Dozuki, which is the iFixit kind of wiki for instructions. And it's step by step with all the details that we didn't have and had to kind of infer by looking at pictures. So the instructions are much better now than they were even like 2 months ago. And that's kind of a recurring theme for I don't want to say home built because this is definitely a business and this is somebody who's building and designing 3D printers. But this is a relatively small operation. This isn't a massive 300-person team building and designing these printers. This is a handful of people who are doing, quite frankly, really good work. It's a phenomenally impressive printer for the price that you pay.
But this printer is not quite what we built because it looks like there's a bunch of add-ons to it. And also, it's printed stuff, a bunch of stuff.
It has pretty, yeah. So I think when we left, the only thing it had printed was that fan shroud.
Right here.
Still the original fan shroud. Right yep, there. That little guy right there. It just blasts air off of the fan onto the tip.
All right.
Since then, I had to do a lot of work on it. The first thing I realized, a couple of things I realized very early on in the setup process, and with every 3D printer we've tested, all the Makerbots, this one and a couple of other things that we've kind of had a little bit of time here and there with, there's always kind of a ramp-up period where you learn how the machine works because they're very precise. They require a high degree of precision. You know, on a vertical resolution, one layer of plastic gets applied to the next, and that gap is anywhere from 1/10 of a millimeter to 3/10 of a millimeter in space. So, you know, you're expecting the motors to move in very small increments, but relatively quickly, and that's why they use stepper motors for 3D printers of this kind. This is a fused deposition 3D printer. What that means is it takes plastic in the top. That's what that big arc of white stuff is. It hooks it with a gear and a tensioner wheel, which the gear turns and forces it down into the hot end, which is that tan and orange thing. Yep. And in the hot end, it's heated up to around 200 degrees Celsius and then forced out of a much smaller hole. So when the plastic goes in, it's 1.75 millimeters. When it comes out of a 0.4 millimeter hole. And typically, the printer just kind of smears that layer of plastic right onto the next layer underneath it. And it does this many, many times. You know, a typical print will be anywhere from 30 to 250 or 400 or 500 layers in 1/10 of a millimeter, or more frequently 0.2 millimeter increments. And by doing that, you can make things that are three-dimensional and real, like, you know, this guy. Well, that's a bad example because he's white. You can't see him. But hand me the big robot, like this guy. So this is the biggest thing I printed. Oh, other things to note. It's a PLA printer. So that just means it's the type of plastic it uses. I think it's polylactic acid. It's based on cornstarch. So when you use it, it kind of smells like corn syrup, like Aunt Jemima. It's non-toxic. It's safe to have around kids. The hot end does get really, really hot. Like I said, 200 degrees Celsius, very, very warm. It will burn you instantly. But the neat thing about PLA is it cools very quickly, so there's less tendency to warp. And what that means is that when one layer cools faster than the layer beneath it, then they kind of pull up on the edges. And warping is one of the problems I did have with this printer. I think it's probably fixable with some upgrades and some software work, but you're not going to get stuff that prints flat on flat. And if you hand me that, or you hold up that Fox, you can see this was printed on the printer bed with exactly like that. It's a relatively simple print. It took a couple hours. And when you flip it over, it looks like the two pieces will glue together perfectly, but there's just enough of kind of camber on the ends that they don't join up right. So you can sand that off and fix it. But you know, ideally, when I've used printers with heated build platforms, then that hasn't been a problem or as much of a problem.
All right, so you did some initial setup. We printed some first things.
Yeah, that Fox is one of the first things I printed, actually.
All right, so it looks pretty good.
And so the first couple of things I found are that this printer desperately needs a filament holder. So if you look over there on the left side of the printer, that wooden thing that it looks like I made in about 5 minutes, which I made in about 5 minutes, holds the filament, lets it spin on the hub, and will feed filament to the printer without putting any tension whatsoever on the extruder head. If you have to feed the spindle, this filament to the printer, what happens is the gear strips out the filament if there's any tension at all, and then it gets clogged up and you have to pull it out with a pair of pliers, and it's a little bit of a pain in the ass.
And then,
So then those two orange things on the top are just filament guides, so that there's a nice straight path from the spindle holder forward to the extruder at the front end of the thing. And those were like 20 minutes worth of printing. I downloaded those from Thingiverse. You can also print filament spool holders. When I looked at those, they were going to take 8 or 12 hours to print, and I didn't want to wait 8 or 12 hours where I was having to feed the spindle to feed the filament to the printer manually. So I just took some scrap wood from my garage in about 10 minutes and glued something up. The other thing that I found is that probably when we were assembling the kit, we did a bad job of getting the hot end, that tan and orange thing. It's only held into the extruder block with friction. So there's not a screw that goes through it. There's not like a lip or anything that it latches into when you cinch it down. It just goes in there, and then you tighten those 3 or 4 bolts on the front of the extruder, and they pinch it in place with friction. So I was having a lot of problems with the hot end dragging across the print head, and I thought I was losing. I was getting Z-axis problems. So I thought that the Z-axis was drifting, but what in fact was happening was that thing was moving down a couple of tenths of a millimeter at a time until it was actually physically dragging through the model, or worse, through the print head. Underneath the tape there's some real gouge marks. You can't really see them. Oh, if you take off that piece of tape that you were just touching, it gets much, much worse. It's worth mentioning that if you do gouge up your print bed like that, it's not the end of the world, because you have to put some sort of tape or something on it anyway. And the tape covers the imperfections caused by me scraping the paint off of the print bed. Once I cinched that down, I had no problems. And I have to say, this printer does something I haven't used before, which is automatic Z-axis leveling. So X and the Y are side to side and front and back respectively. Z is up. Typically, most of the problems you have when you're printing are because either your Z-axis isn't level, one side is higher or lower than the other. One side of the bed is higher or lower than the other, because again, you're talking about a tenth of a millimeter, 100 microns. Small errors add up very quickly, and because of the way the printing process works, where you apply one layer and then you apply another layer on top of that, those mistakes magnify over time because they're kind of additive. That big silver sensor on the side of the extruder head is actually it detects the metal in the print bed. So when you get close, it knows, okay, I'm near the metal now. And then using software and a little bit of manual configuration, you tell it, okay, so the actual print, where you want to be is actually 0.3 of a millimeter below this print head, below where the sensor detects metal. And it accounts for build platform problems much better than doing it manually. It's much faster. And once getting it dialed in was a little bit tricky, but once I got that dialed in, it's been much more turnkey in that I can mash print on something and go.
All right. So we also demoed some software when we built this, and in the very first print, you mentioned software. You mentioned the software here is much better than the software in terms of the leveling.
So that's software that's on the printer itself. The build platform, everything on the printer is controlled by a board that's inside the metal layer. It's called the printer board. The people who make the Printrbot actually designed the board, and it's kind of become a standard for RepRap and other type 3D printers. It's all the stuff you need to control a 3D printer that's much more complex than this one, including multiple extruder heads, a heated build platform, and all that stuff on one board rather than on a bunch of different daughter boards, which makes the assembly a little bit easier. It's less stuff to wire up and fewer components overall.
Well, this one only has the one print head and also no build platform. That's something that can change.
Yeah, they haven't released upgrades for this particular kit. I think there is actually a heated build platform a kit that's in the works for this. You need to replace the power supply because the power supply that comes with it isn't powerful enough to drive the extruder and the heated build platform. But like, there's nothing to keep you from taking this design and adding to it. The software is all configurable. Like, if you wanted to make the build platform bigger, you would need to make a new y-axis, that big horizontal piece of metal, and a new x-axis, and put some new rods in, and then just tell the software, hey, my build platform's a whole lot bigger than it was before. That's totally doable. It's a pretty nice design in that standpoint. I know that there's even so the heated build platform is a $99 upgrade. Multiple extruders, I don't think they have for this model yet, but they've done that for other printers in the past, and it wouldn't be particularly tricky to do. Multiple extruders are much less useful than a heated build platform in our experience. The heated build platform will help cut down warping and makes it easier to stick stuff, and it lets you use some other stuff that's a little more durable. For example, you see that there's blue painter's tape on this build platform. That is the most adhesive, best thing I found to get prints to stick and still be removable with a minimal amount of force. The problem with the blue painter's tape is that it's really, really fragile, and usually when you peel the print off, the tape comes off too.
So you have to reapply it
every single time. You have to apply at least one piece, usually 2 or 3. You'll also want to use some rubbing alcohol. So this is just 99% isopropyl. You put it on a paper towel, you wipe the surface, the build platform first to get oil and residue and finger grease even off, and then also wipe the top of the tape down off to get, again, the finger oil is enough to make stuff not stick. I tested a ton of different tapes with this. The one that I found that worked best is this stuff. I think this is a 1.85 inch roll of Scotch Blue multi-surface painter's tape. It's not the not sticky stuff. It's not the super duper sticky stuff. It's the mama bear of the, I guess it's the baby bear of the 3M tape world. It's number 2090 if you're looking for tape and have a printer and have problems. I went to Ace and bought $50 worth of tape, and that was the one that was the winner. So I mean, the good thing is it's not particularly expensive. So if you are putting it on, taking it off, putting it on, taking it off, it's not like you're losing a ton of money. It's just a hassle, and it takes 5 minutes per print, basically.
Right. So you have software you want to show?
We can talk about software. I mean, I think that's the main gist of the printer. Like,
yep.
It's
a good printer.
The prints have been pretty good. The software that they recommend you use to start with is this thing called, it's either Repetier or Repetier. I'm not sure. It looks like it could be French, who knows. It's called Repetier Host. I'm using the Mac version here because I'm running on a Mac. But you set this up and you tell it how big your build area is. On this printer, it's 150 millimeters and change by 150 millimeters and change by 150 millimeters and change, which is, I think, 6 inches by 6 inches by 6 inches,
yes.
Thereabout. And then with the software, you can drag, at least on the Windows side, you can drag. You can drag your files into the window. No, I got to do it in the thing here.
Just open up your standard STL file.
Yeah, so you import. I don't know why I'm not seeing this. Yeah, it uses STL files. Here we go. Add STL file over here. The interesting thing to note about this is that the Windows version of this software and the Mac version of this software are almost, but not quite, completely different. So here is, and the Windows version is the superior version, I think.
Wow. It's clever animation.
It does a little bit of clever animation. It tries to lay it flat.
Okay. So if you dropped in an STL file where there was no obvious flat base,
it's going to put whatever the down in the STL file is down. This seems to be less good with support materials and stuff like that. If you have something that doesn't print, that needs support material to print, you're going to probably want to do that manually in Mesh Mixer or something like that, rather than hope that the software does it right. For what it's worth, the other software that does support material isn't awesome either. So, that's not a big change.
But this is a file that you knew would print, for example. So this is something you can download. You do it from Thingiverse.
Yeah, this is it's LaFab Labs Makerbot, articulated Makerbot action figure. And they have it in 2 sizes. This is the 150% size. They also have one that is a 60% size. It's much, much smaller. But this was printed as one piece, and it literally prints like this. And then Norm has in his hand something that he can pick up and is articulated. the legs move, the arms move, the head turns. I think it's 12 pieces maybe, I can't remember.
No assembly required.
No assembly required. It's pretty impressive. And this was the first big thing that I printed. It worked pretty well. Now, if you look at the bottom of that, again, you'll notice that there's some warping on the butt of the robot, where the back edge is kind of curved up a little bit, and you can't necessarily, the bottom of that robot should have been flat, and it didn't end up flat just because of the curling as the plastic came up over the 32 hours that took to print.
Curvy robot butt.
Yeah.
So when you said there's a 150% size one, can you scale that in the software?
Yeah. So part of what Repetier does is Repetier, whatever it's called, is lets you place the object on the platform. So for example, I could make this a 0.5 size, and it's going to shrink down immediately, or I can make it 200 times as big, and it's going to be.
Is there an easy guide for real-world measurements?
No, that's one of the problems just in general with this kind of software is you need to do that when you're doing the model. So Sean Charlesworth, who does a 3D printing column for us, had recommended that you put a static size object in your model so that you know how big it is and you know what the scaling factor needs to be.
And you can easily cut that out.
And you can easily cut that out later. You need to know that coming in. You need to know there are, I think, at least in the Windows version of this, there's basic tools that help you go from 1 centimeter as the base unit to 1 inch as the base unit, but it's not apparent, and there's some trial and error involved, which is not awesome when you're talking about a thing that takes 32 hours to print.
This is 32 hours.
That was 32 hours, and I think 95 meters of filament, which was probably about a quarter of a roll, if I had to guess, quarter of a kilogram. We could weigh him and tell you how much he weighs. So the Repetier, you do object placement with that, and I'll show you. You can also do add multiple files at once. So these are the gears for the race car here, the one that doesn't work very well. It's going to add them, and then I'm going to hit auto position, and it'll lay them out in what it thinks are the available print space on the platform. And I can keep adding more stuff so that you do multiple things at once and kind of and there's less time where you're having to kind of fiddle around with it and more time where it's actually making stuff.
When we're talking about time it takes to print, height is the biggest factor.
It's really more about volume of plastic than anything else. The height is usually indicative, but sometimes you can have, for example, when you printed the gear, that big orange gear on the side of this thing, too many things. When you printed that big orange gear, that was too much.
That was a lot of time.
It took a long time. Yeah. This was probably 10 hours of printing, if I had to guess. And
not a perfect fit.
No, so that's one of those things that comes over time. I didn't glue that in place intentionally, but there is enough surface contact there to glue that. Getting stuff to fit mechanically and having the right kind of connection one-to-one and all that is really hard and takes a lot of printer dialing in and a lot of time. And I think with the warped nature of these prints, if you look at those wheels, especially the big ones and the gears, they're convex. So the edges are further away from the center. You can't really see it, but you can a little bit in the middle. If you look at the center of that wheel, there's definitely a hump in the middle. It's not by design. That was the flat edge that was on the print bed. So stuff's coming up the edge. Again, if you put a big cardboard box around the printer to cut down on drafts, that will help reduce warping. But this is not a printer that has a design that's really conducive to going inside a sealed area like the Makerbot or something like that.
Right.
So your mileage may vary. If you're in a room without air conditioning or without a fan that runs, you'll probably have better results. I found that sometimes the day were better than others just because the room was a more even temperature through the whole print. The auto layout on Repetier isn't smart enough to reorient stuff. So for example, you could fit more in here if you rotate stuff around. And there we go over here. I don't know that you can rotate in this version. On the Windows version, there's rotate buttons, but it looks like you can't do that here, or at least I don't see how to do it when I'm standing here flailing. So that's Repetier. Once you have that set up, you lay out the build platform the way you want everything to print. and then you do this, you mash, let's see if we're gonna fit. Nope, too many objects. All right, let me clear off some stuff here so we can print. There we go, I think that'll do it. Okay, so once you have the objects laid out the way you want them, you hit this slicer button. Slicer is another piece of software. It's an open source, I think, piece of software that actually takes the three-dimensional models and converts them into tons and tons of layers, of two-dimensional layers of tool head movement. So it just basically says, G-code. It says here we're going to follow this path, and we're going to do that, and then we're going to go up 1/10 of a millimeter, and we're going to follow that path again. You hit the button to run the slicer. It takes anywhere from like 2 minutes to 20 minutes, depending on how big the print is.
Also volume-based? Complexity?
It's more about complexity. It's about how many times it crosses perimeters and edges and stuff like that. This uses profiles, and this is where one of the tricky parts for this printer came. On the Printrbot webpage where they talk about the Simple Metal, there were, let's say, I think 3 different profiles for slicer listed. I tried the first 2 and got terrible results with both of them. Talked to Jeremy, who had bought the same printer and had been messing around with it for a couple of days before I got a chance to test it out. And he recommended the third one, which is great. The third one, which is called, I think, Simple Slow, actually works really well. I have it set up here. It's not a 0.1 millimeter resolution profile, so you're only getting like 0.2 millimeters and change vertical resolution. But the results are really good. The amount of infill is good. It looks nice. Like it was, you know, when you're setting up a new 3D printer, eventually you reach a point where you're just like, okay, I just want something to print and look okay, or I'm going to be really sad and I need to walk away for a while and maybe start drinking. That got me to that point, and from there I was able to dial in a little bit more.
And the profiles that and also your adjustment for the infill tells you how much actual weight and mass it uses.
Right. So there's a ton, like we can go into G-code here, into Slicer, and I'll show you some of the settings. It looks like I have like 10 Slicer windows open right now. There are 3 main groups of settings for Slicer. One is print settings. The layer height is that vertical resolution we've talked about. The first layer height you usually do a little bit thicker just to improve adhesion and to help cut down on the warping. But then you also control things like perimeters. So perimeters are the outside edges, and that determines how thick the walls of your print are. Once you get inside, and I have a partially printed something here somewhere that we should be able to cut open, I thought. Maybe I didn't bring it. Anyway, once you get inside, there's a rectilinear grid of it's just a crosshatch, basically, of diamond-shaped X's that fill the void inside. And you do that with the infill. You can do stuff that's zero infill, like make a vase. Or you can do stuff with tons of infill, like that knob. The knob for this guy and the spring are both 100% infill. So there should be no air inside that plastic. And it feels a lot heavier as a result than something that's a similar size. It also means it's closer in strength to something that's, say, injection molded or cast or something like that. The more infill and the more perimeters and the bigger your object, the more time it takes to print. Because the speed of that tool head is a relatively fixed variable. So it's not going to go faster if you have more stuff. The more filament you put down into the object, the longer it takes to print, basically. There are literally dozens of options in here. You can go down deep, dark rabbit holes testing this stuff and figuring out what works and what works. The best bet is to go hit the message boards for your printer, whether it's this one, a Makerbot, or whatever. Find people who've done that work and then just draft off of them, because testing a single setting change can take 20 or 30 minutes, and the process is load a 20 millimeter test cube, which is a cube that is 20 millimeters by 20 millimeters by 20 millimeters. Load it up, slice it, print it. You're looking at probably 40 minutes there, depending on what your infill setting is. And then break out the calipers, measure all 3 axes, try and figure out what went wrong, adjust one setting, and do that over and over again. And you can lose days really quickly.
Just calibrating.
Just calibrating. Once you get it good, and we're in a pretty good place here, because the problems with that car, I think, are due to warping, not necessarily configuration problems. You can do stuff like this orange bracelet. So this is another printed in place thing, but it's much, much finer detail. If you look at the Makerbot, which was printed in place, it's huge joints that are really big and kind of forgiving, and the gaps between pieces were very large. On this, the gaps between pieces are really small, and it doesn't flow like a piece of assembled jewelry, but it's close. And the more it's worn, the more that plastic will kind of wear down, and the better the friction will get. So that, to give reference, is an egg cup that was printed on the Replicator 1 in ABS. The bracelet that you're getting ready to hold up is printed in PLA on the Printrbot. The 0.2 millimeter profile that I'm using for the Printrbot, because they're using a relatively slow motor speed for the printhead movement, actually gives really good results that I think are pretty comparable to the 0.2 millimeter resolution on the Replicator 1 using Makerware. It's a little bit of an apples to oranges comparison because we're using different software, a different printer. It's all everything's different. But at the end, you can compare the two things that are printed and see. So yeah, that's the settings. Like I said, you can go down deep dark holes. Once I had all that set up, one of the neat things about this printer is it actually works with Octopi. Octopi is a Raspberry Pi distribution. It's a version of Debian Linux for the Raspberry Pi that supports 3D printers, and it basically turns a normal, normally you plug this into a USB connection into the computer that you're running Repetier on, and then control like temperature and loading filament and all that stuff using the computer connection over USB. With Octopi, you connect a $25 Raspberry Pi or $35 Raspberry Pi to the printer, connect that Raspberry Pi to your network. I have a Wi-Fi dongle, but I think it's plugged into Ethernet here because I didn't have Wi-Fi set up for our office. And then you can, it turns it into a print server, basically. So instead of using the desktop client, I just log into a web page on my local network. That's the Raspberry Pi. It's 35 or 40 bucks on Amazon. There's 3 or 4 different versions.
Yep, USB right there.
This is the Rev A board, just because it's one we had laying around. The Rev B has a couple more USB ports and a little bit more memory. It's a little bit more capable, but it doesn't matter which one for this. The Rev A has been more than sufficient.
So you're sending commands from remotely to the printer, actual commands to adjust it.
I can do that right now if you want to move your arm out of the way.
Also send files over to print.
Yeah, so if, Joey, can you go back to that split screen again? And I'll show how Octopi works. If you have your router set up, you can do it from anywhere in the world, which is kind of neat. This guy right here is Octopi. And you can see there's a couple of different parts of it. What it's showing right now is just the temperature for the window. I'm going to set it to run, warm it up, get it to 200 Celsius. That'll take maybe 2 minutes, and while I'm doing that, I'll show you the rest of the stuff that's happening here. On the left side, it tells you kind of what your connection state is like. This uses a USB serial connection. I think I lost my connection here at some point, so I'll reload. There we go. So I'm connected to the printer. I know that the machine's ready to go. If I want to send G-code manually to the printer, then I can. I don't have to. But I can do things like home the axis. And because I have that little Raspberry Pi camera on the print bed, I can level the print build platform. And the camera moves with the build platform, which means you get kind of interesting time lapses and stuff like that. We'll level the Z-axis now. It's going to make a wobbling noise. I got to fix that, but I have the parts to do that here and didn't have them at home. And this is again where that Z-axis auto leveler comes in. It's super handy.
Oh.
Yeah, it's just
pleasant sound.
Yeah, it's not great. And then I can drag. So let's say I'm using Slicer. I want to print something. I'm going to drag this knob into Slicer. It's going to slice it up. Export G-code. Knob, stuff to demo printing. Perfect. That'll take a second. Oop. Well, I don't know what that is, but okay. So theoretically, I did that, and then you drag it over here, and it just pops. Oops. It pops up. You can drag and drop it into Octopi. Once it shows up there, then it shows up over here in this left column. And I'm going to find, I think there's a norm head in here somewhere. Here we go. So let's load this guy up. and it's going to zero out the print platform. I didn't put an extra piece of tape on there. It's going to level out the build, and then it'll also record a time lapse of the actual print taking place. So I have that here. I'm gonna download it to this computer, and you guys can see it. So yeah, it basically gives you a way to monitor the printer remotely. There are a bunch of other solutions that do something similar. This one's the probably cheapest to implement that I've used so far. I'm testing out a couple of others right now that we'll talk about at some point in the not too distant future.
Pretty crappy camera.
The camera, so it's worth mentioning, the whole thing runs Linux. This is a 5 megapixel camera. I printed the housing and the little mount and all that stuff. Jeremy Williams, friend of the site, had uploaded that based on some other projects to Thingiverse. It's probably not going to do real well because there's no tape, but it works well enough that you can see what's going on. If you want better resolution or better quality, then you're probably going to want to, you can adjust the settings in Linux and get something that's still not going to be great, but is better than the 640 by 480 video that we have right here. Or you can hook a real webcam up to it and then use that. The Raspberry Pi is a little limited in the amount of processing capability it has for that kind of stuff, though. So may not be the best. Yeah. Do you want to see the, here, look. We're going to go fast now. One of the neat things about this time-lapse capability is because it actually knows what the printer is doing, instead of just knowing what time it is, you can set it to do things like only take a shot every time the z-axis changes. So you have models that look like they grow up from nothing, rather than the print head running around kind of spastically, which is kind of neat, I thought. And you can see it's writing on the print head, so you're getting a lot of weird movement in the background.
The movement
as a
is
result.
around the back, yeah. That's actually really interesting.
It's a real weird effect. I'm not sure how I feel about it, but
I like it. You're seeing things rise up from the ground.
Exactly. So that's kind of where we're at with the Printrbot Metal Simple. I'm going to turn this off and stop the print because it's just making a mess. But it's worth, like, this is a good thing to be able to do, because frequently, a print can take 25 or 30 hours for something big. You don't want to have to sit and babysit that printer the entire time. Being able to check in on it is incredibly useful and powerful. And if you set, like I said, if you set up your router right, you can do it from your phone. Octopi is a responsive page, so like when you shrink it down to fit on your phone or something, it just kind of works.
Yeah. Not only can you check in, you can modify and you can pause and then resume later.
Yeah. So I did one on that robot. I printed 5 hours, paused it, and then came back 10 hours later after I'd slept and printed some more. It's like I said, it's a phenomenally good little printer for $600. And I haven't.
You can do a lot of cool things with it.
You can do a lot of cool stuff. 6x6x6 is a really massive build area for 600 for what you're paying. And the fact that it's an all metal construction rather than the traditionally at this price point you're looking at wooden with nut slots, and those printers get really loose over time and are kind of finicky to maintain. So at $600, I think that this is right up there with the iPad or a gaming console or something. If you want to get something for your kids to noodle with, and they're into building 3D models of things, you can spend $600 on Shapeways really, really fast. And this gives them the benefit of being able to make something, see how it works, take it back apart, print it again, make it, see how it works. And it takes a lot of time. So kind of you want people who have a lot of free time to be using it.
Well recommended. The Printrbot Simple
Metal
with accessories that some were even 3D printed.
I think kit is probably an okay way to go now. I think the instructions are really good if you're even a little bit mechanical. If you can build a PC, you can put this together. While you're waiting for your kit to come, build a spindle that is literally one piece of wood that was cut twice with a dowel. It works great. And then you can print some other accessories for it that will make it work better once you get it. And it comes with a little bit of filament. I bought a bunch of different filaments from Amazon. They all work pretty well with it. You can get a kilogram of PLA plastic now for about $35, $30 to $35, depending on the color. And yeah, it looks pretty good. So So that's the Printrbot Simple Metal. It's $599 or $540 for full assembled or kit.
You watched us build it, and now it's been tested.
See you guys later.
Bye.